For this video, we're going to investigate how to find an equation of a tangent function graph. Now, this particular graph actually gives us 3 points that are on the graph itself, as well as two asymptotes. Now, if you go from one asymptote to the next asymptote, that's actually one period of the graph. So after you pass this asymptote, the graph just repeats itself. So now we just need to be able to use this particular period here to determine what the equation is. For a tangent graph, if you start off with one asymptote and you go a quarter of the way to the next asymptote, you get the first point. Then another quarter of the way, you get the second point. And then another quarter of the way, you get the third point. And then after that, you're at the next asymptote. Now, this information is useful for us because we can actually determine a lot of features of the graph of the tangent line just by what we have here alone. Now, one key aspect of the tangent graph is the reflection. To determine what the reflection is, we have to see which way it's going. Like if we consider the parent tangent graph function, we expect the parent tangent graph to look something like this. So basically, if there's no reflection, then the graph will proceed in the same direction. But if there is a reflection, then we expect the graph to look something like this. But since we see that the graph is going this way, then we see that there's really no reflection. So for reflection, we can just put none. All right. Now, another aspect to consider is the vertical shift. Can we determine what the vertical shift is? Well, if we can consider the parent tangent graph, it looks something like this, and it intersects the x-axis at the origin. So whatever the vertical shift is, it's really going to demonstrate how far up or down this middle point has been translated. So we know the origin is here. To get to the middle point, it looks like we actually have to go down too. So vertically, it looks like we have been shifted down too. So for the vertical shift, we can just put -2, which represents 2 units down. And then likewise for the horizontal shift, we can see how far we go left or right. So we see here that this x coordinate is -4. Yeah, so that means that the horizontal shift is -4. Okay, now what about the period? To determine the period, we need to know the distance from this asymptote to this asymptote. So if we look at this, it looks like we're dealing with the location of this asymptote. It looks like it's 5/4 pi, because this is 4/4 pi right here. So this should be 5/4 pi. Yeah, because we're counting by pi/4. So we will start off with the 5/4 pi. And then what we're going to have to do is we're going to have to subtract whatever this is this looks like it is, let's see, if we start here, it's like negative 4 over 4 pi, and then negative 5 over 4 pi, negative 6 over 4 pi, and then negative 7 over 4 pi. So we're going to subtract negative 7 over 4 pi, or 7 pi over 4. And basically, if you subtract the negative number, that's the same as adding. So essentially, we're going to add 5 pi over 4 plus 7 pi over 4. So that gives us 12 pi over 4. And then we might ask ourselves, what is 12 pi over 4? Well, we can simplify by dividing 12 by 4, and that is 3 pi. Okay, so the period is 3 pi. All right. Now let's check out the vertical stretch. So typically, if we're dealing with these 3 points in the middle, like for the parent function, the vertical stretch is just one, meaning that like basically the the difference in the y values of this point and this point are just one usually. But but if there is a vertical stretch that's different from one, then it's just going to be like whatever the difference is in these y values. So we see here we're dealing with 0 here, and then we're dealing with -2. We can subtract 0 minus -2. That's equal to 0 plus 2, which is equal to 2. All right. So now, um, so now, if we want to consider the equation for this particular tangent graph, we're going to have to consider the just a general equation for tangent functions, and that is y is equal to a tangent b, and then we can put x times x minus, let's see, and then plus d. So now the value of a, that corresponds with the vertical stretch. Now, if there was a reflection, we would also multiply the vertical stretch by -1, but there is no reflection, so it's just going to be 2 for a. So it looks like we have a is equal to 2. The value of d, that corresponds to the vertical shift. So d is equal to -2. The value of c for this particular formula corresponds to the horizontal shift. So c is equal to -pi over 4. All right, and then to get the value of b, there's actually a formula that we would use when we have the period. And the formula is like this. The period is equal to pi over b, or we could say pi over absolute value of b. So if b is negative, you'll just make it positive. And and then for this one, we would just consider, we would just consider the information that we have. So we have 3 pi is equal to pi over b, because we know, well, yeah, so 3 is equal to pi over b. So we're actually expecting b to be positive here, because b also like can represent a reflection about the y-axis, but it doesn't look like there's any reflection about the y-axis. So b is actually going to be positive. So that means the absolute value of b should be positive as well. Yeah, so basically we have 3 pi is equal to pi over b, and then we can just solve this for b. So basically it's like, to solve for b, um, we can multiply both sides by b and then divide both sides by 3 pi. So essentially we end up getting b is equal to pi over 3 pi. And then we can just cancel out the pi. And since everything has been canceled out in the numerator, we just put 1. So b is equal to 1 over 3. So now it appears that we have enough information to write out the final equation. So a possible equation is y is equal to 2 tangent of 1/3 times x, and then it's like minus negative pi over 4. When you minus a negative, that actually becomes addition, so it's plus. So we put plus pi over 4, and then minus 2. Yeah, so whenever the horizontal shift is negative, you put plus, and if the horizontal shift is positive, you put minus. Yeah, so we end up with this particular equation, and that should represent the graph of this tangent function.